Hi, everyone. We're going to start in just a few minutes. We're waiting for a few more people to join us, so bear with us. Hi, everyone. Thanks for joining us for the Community TLV Q1 Meetup. We're thrilled to have you. Before we start, we're going to have some community updates. First of all, we're trying to understand if physical event pre-corona times is still possible this year. And we need your inputs. So please, if you can devote a minute to answer this survey through this QR code, this will really help us understand if we can do a physical event this year or not. You can use either the QR code or the URL above, bit.ly/community TLV-event survey 21. Second of all, we have the next meetup already in place, the next community meetup. It's going to be Cloud Native and OSS together with Production Django. It will be next month. This is the event of the first hybrid event after Corona times at the offices of Aerospike at Brain Embassy, Tel Aviv. The physical attendance is capped to 50 people, according to all Tav Yarok regulations for any COVID-19 events. So please put in your calendars, 20th of April, 5:30 p.m., and we will really glad to see you all there. Last update for now, we have an ongoing call for papers for the meetups of the community, such as this one. You're more than welcome to add the link to the favorites and submit any ideas for talks that you have. The link is papercall.io/community/TLV/meetups. And please, we will happy to hear from you. Okay, so before we start, this is what's going to happen in the next session. We're going to have 3 talks from OSS, Cloud Native and OSS TLV, Statscraft, and DevOps TLV. After that, we're going to have a short Q&A panel with all of our panelists with questions that you're going to send us through the Discord channel. That's it. So if you have any questions, please go to our Discord channel in bit.ly/community TLV-join Discord, or also in the banner here, and you can submit any questions that you have. Okay, so let's start. I'm gonna introduce the first speaker that we have, Yair Etziony.
Hi.
Hey Yair, what's up?
I'm fine. One person is writing to me that in his WhatsApp that he doesn't see that we started the transmission. Maybe that's something. Maybe it's his problem. Okay. Yeah, he did refresh. Yeah.
Okay, cool. So Yair, you're the head of operations at Polar Quad, Germany.
Yes.
You're gonna speak to us about how to define DevOps concept better.
Yes. So yeah, the talk is more conceptual, philosophical, because I studied history, and for me, as we will see in the talk, I see, because I'm a consultant, I've seen so many mistakes done by companies who are running to do DevOps, and then they don't understand why they failed. Oops, their DevOps transformation. So the whole idea is to ask the right questions and to see if we can somehow break concepts that people do in at least in Europe. I could see that these concepts repeat themselves, same anti-patterns. So yeah.
Sounds awesome. So take it away.
Oh, okay. Yeah, hop. Just a second. So just a second, it's uploading. Do you see my screen?
I can see your screen, so I think everyone could.
So as you can see, Polar Squad, we say that we're the best DevOps company according to us, but the actual talk will be DevOps, a search for a better definition, and I added the quote that I try to live by: having no destination, I'm never lost, by Zen philosopher Eco. So a little bit about myself. I'm Yair Etziony. As you can see, I have 80s IBM t-shirt, one of a kind. I'm head of operation for Polar Squad Germany. Polar Squad is a consultancy agency from Finland, experts in anything that is SRE and DevOps. I have around 25 years experience, mainly doing quality assurance and DevOps and system administrator work, originally from Israel, but right now living in Germany. I studied German history of thought. I'm one of the organizers of the DevOps Berlin Meetup group, actually make music, and this is my Twitter if you feel that I'm interesting and not just talking jabba jabba. So let's start. So like every story, I believe that this story needs to be told from a personal point of view. And my personal point of view is that in 2014, I decided to never work again in the world of IT and software development, or high-tech as we call it in Israel, and decided that I'm a professional musician and that's it. I moved to Germany a year later with no aspiration of working at all in the field, but life is life, and I found myself working in Berlin in various startups as quality assurance engineer, but there was a new role coming called DevOps engineer. So I did a bit of research and I found out that at least the way it perceives is some sort of a system administrator, just with new cool tools. And I said, okay, I can do that. I worked with hypervisors, I worked with containers in the past. And all the roles I did were basically not so interesting until I met Polar Squad. We have a heavy metal logo, as you can see. And I was hospitalized with a stone in the kidney, and I started to really add a lot of free time and a lot of bandwidth, but nothing else to do. So I watched a lot of videos, read a lot of articles, and started to think about things. And before I want to go forward about my research, I'm an historian, so I will give a bit of historical background. So the first thing we want to talk about is we moved from sequential way of doing software, like V model, waterfall. We moved to this kind of a agile or loop, feedback loop kind of a thing that looks a bit like the infinity, but this is very sequential. So this is the first thing, like how do we get into the situation of having this? And let's talk about it a bit. So now we have, we moved from waterfall to agile. And then we moved from buying hardware. I'm old enough to know that we used to buy hardware for the servers. It took us sometimes 2 months to get the machines to Israel. Then we moved to hypervisors, virtualization. Now we're thinking in terms of services, containers, but even deeper than that, we're buying services. So another thing that is changing the way we think about what we have and gives us more opportunities. Another thing is the version control. Git changed the way we're thinking about version control, and it's slowly starting to fuse devs and ops, the biggest enemies ever. And what we're starting to see is standards and API-driven work and automation. Of course, when you have all this together, you start to see the picture from the technological side. Okay, and a little bit more historical background. So in 2003, Google started the reliability engineering team. The idea is what happens when an engineer needs to work in an operation, kind of a society, area. So that's sort of a way of looking at things. 2009, Flickr deploys 10 times a day. They were looking for ops who think like devs and devs who think like ops. And in 2009, Patrick Dubois started asking questions and trying to build a community in Twitter around the idea of agile system administrator, and somehow he created DevOps. DevOps, okay. So another thing that we remember from history is the integration L. Since I was a quality assurance engineer and integration specialist in a couple of companies, it was always the last integrations that were the most horrible. Like there were days, weeks where people were just losing it, and we really want not to see this stuff. This is really bad, and this comes from the sequential way, because you move the software from parts to parts, but at the end of the day, the devs takes the binaries or the code and they throw it through the fence to the operators, and operators needs to install it, and this is create an unbalanced situation between those two powers. So now we want to ask ourselves, what is DevOps? Like, what's the most common, at least, definition? And the definition that I know is this one. DevOps is a loose set of practices, guidelines, and culture designed to break down silos in IT development, operation, networking, and security. Sharing and collaboration are at the front of this movement. So, and we always have this nice build, code, plan, have fun thing. And these are the 5 pillars of DevOps: culture, automation, lean, measurement, and sharing. I can share the slides later so you can read it, but it's common fact, or at least it's very known. So now comes the creature that would implement all these things, and his name is the DevOps Engineer. And who is he, by the way? What's his story? So DevOps engineers, are they sysadmins or not? I don't know, but if you try to hire a DevOps engineer, you will fail because you might hire the wrong people. Because a lot of the times you're building a silo within your organization that is just a DevOps kind of a silo, but what is it really? And the last thing that I noticed is that the role of DevOps engineer it's actually empty. Everybody defines it the way they want, and nobody actually knows what it is. Most of the time when I worked as a DevOps engineer, I was just a system administrator. But if they want to hire a system administrator, why do they hire a DevOps engineer? Okay, let's see. So one thing that is super important. If you need people that are expert in AWS or Docker or Kubernetes, you will find them. But are these people connected to DevOps? It's a question. We'll try to answer it soon. And there are rules around that make sense. For example, cloud architect or an SRE or an infrastructure engineer or a system administrator that is working in the cloud. That's fine. But what is the relations between those roles and DevOps? And an important question I ask is, how can you engineer culture? I mean, they tried to do that in China in the Cultural Revolution. It didn't work. So I think we have a problem here. And what does it mean to actually engineer culture? And who should engineer culture? Yeah, Colossus maybe? I don't know. So, and another question I ask is DevOps and sysadmins, what's their relation? So if you want to have a DevOps transformation project, why do you hire sysadmins? And yeah, from my experience, most of the time I worked as a sysadmin and not a DevOps engineer. I was an SRE, but I was a sysadmin. So let's give two examples of a job offer. So this is a classic job offer I get quite a lot in Berlin. I don't know about Tel Aviv, but strong experience working in the cloud, experience with the Terraform, experience with containers, Docker preferred, Python, Golang, Ansible. Okay, but where is this job is for the definition of DevOps engineer? I'm not sure. Here is a better job from my perspective. So Netflix are looking for a senior resilience advocate, and notice focusing on the people within the company. Netflix as a socio-technical system is formed by the interaction of people and software. And there's always the idea of ongoing change. So I think this role much more is fitting to the definition of DevOps we had. It's not saying you don't need a sysadmin or a cloud engineer. It doesn't mean you don't need to be at the cloud, but it says one thing: you need to take care of your culture. And the question we in Israel like to ask is, why like this? So a lot of the times we like to solve problems with numbers. Let's just do 6 DevOps engineers, boom, solving all your problems. Then we have Brooks' law. When you add manpower to a late software project, you will make it later. And the third one is a lot of companies, they don't reflect on what they want to do. And they don't ask why we're doing it. But why? So we confuse the methodology with the praxis. We confuse a philosophy of software with how we want to release software. DevOps is a methodology, and it doesn't mean you need a DevOps engineer to actually create it. And from my experience, there's a good chance that if you have a DevOps engineers team in your organization, you're not doing DevOps at all. And I would even add that if you have a really good DevOps engineer team, at some point they will automate themselves out of the work. So in a way, hiring DevOps engineer, I don't know. And the key metrics, I will go this, it's less important, but the key metrics are delete time, deployment frequency, time to restore service, and change failure rate. For me, these are the most important key metrics about the DevOps methodology. And now I want to take it a bit to another place and ask a question. Just a second. Because there's also the historical shift, and there is also one definition that is the definition that comes from above to down, but there's also the way people look at things. So when I was in Berlin in 2015 and started to look for DevOps role, the tools that were associated with DevOps were Chef, Puppet, AWS mainly, and Jenkins. Nowadays, I would say it's more maybe Google Cloud, I mean AWS also, but Kubernetes for sure, Helm, for example, and Terraform. So in this case, we can see that there's always a shift. And what will be the tools of 2030? Nobody knows, yeah? But it's still important to understand that the tools of today might not be the tools of tomorrow. And what is not DevOps for me? all these tools are not DevOps, okay? They're not really part of the DevOps revolution or change, but it doesn't mean we cannot use them in our DevOps journey. They're just not crucial. And now for tools and culture. So in Berlin right now, there's a lot of people that, since they understand that doing things only with technology is not enough, they only go to the other side. And then only culture. And I don't think this is the way, because when you have tools like Kubernetes, you have an amalgamation where both culture is changing. And these are not two different beings. There's as basically one creature. And developers and operation. So one customer told us, I would like to have an API call and not to open a ticket. And I think this is the place where we want to go together. The whole definition of developers and operators is changing right now. And Kubernetes' Git are changing the way we think about operating in the sphere. And I think very important saying is you build it, you run it. So instead of being a classic operator, I become a platform engineer, for example, not a DevOps engineer, but a platform engineer. And my role is to give the developers the tools in order to have an automatic deployments and infrastructure. And DevOps and SRE, let's do it fast. Unlike DevOps, SRE is a very well-defined role. It deals with reliability. It's part of the DevOps movement, yet it's older. I think I don't have much more time for this, so I will just jump. And one more thing that is super important about SRE, don't just copy the Google books. You're not Google, most likely, so it won't work for you. Take the ideas. And the last thing I want to talk about is the DevOps transformation. So it's a team effort. Yeah, it's not just one team's work to create it. And this means that it has to come from the management by itself. And it has to ask the question, what are we trying to achieve? Because automation is just half of the work here. We want to change the way people think about things and working together as developers and operators. Don't give up. Yeah, there's a lot of mistakes. You can learn from them. Failure is the best teacher. You should have a good feedback loops, small iterations, and remember, although we want to achieve that, not everything is measurable. And I'll say it again, not everything is measurable. But you want to have happy people at your team doing something they believe in. And of course, asking the right question, like, would SRE fit what I'm doing? Is Kubernetes what will make my organization better? Microservice, and how is my stuff is future-proof? So I will just jump this. If you don't think about the future, you will be like Lyft, who started to have this in one of their stock meetings. The reliance on AWS brings potential risk for Lyft because of the amount of money they spent every year. And will the journey ever end? No, we're starting the second age of DevOps, and it will never end. It's a constant change in a way. So thank you very much.
Thanks, Yair. It was very insightful and a lot of food for thought. So thanks for that. Next ahead, we're going to have Itiel Shwartz. I think the previous talk is really connected to it. Hi, Itiel. What's up?
Hey, pleasure to be here.
You're going to talk to us about the journey you had starting your own company, Komodor.
Yeah, exactly.
Awesome.
Sorry about that. So I'll just get started.
Yeah, take it away.
Can you view my screen? Like I shared it? But
not yet, just a sec. Here you go.
Okay, great. Thank you. So
enjoy.
Second. Thank you. So hello, everyone. Thank you. And my name is Itiel Shwartz. I'm the CTO and co-founder of Comodore. We are a startup building the first Kubernetes native troubleshooting platform. I'm a big believer in dev empowerment and basically moving fast. And in my previous life, I worked for eBay, Forter, and Rookout. I have a lot of backend and infra experience, basically what you can call like a DevOps. And I really like Kubernetes. So what are we going to talk to do today. So we're going to start with where was Comodore like last year, and when we started the company, we needed to build a product from the ground up. I'll walk you through like the first decision we needed to take, and what of them turned out to be a good decision and what not so good. We'll talk about CICD, which tools are you using and why. Then I'm going to jump to monitoring, a couple of things worth mentioning, and then wrapping it up. Basically, if you are building a new product, a new company, a subsystem in your company, I think this talk will be very, can give you a really good insight regarding the things that it's worth considering and the different trade-off between different tools. So like how did the journey start? So we started building the company last year. It was clear to us that we want to use industry best practices. We'll share the things that we learned and how and why. And I would say our main goal was quite simple. I think like a lot of young startups or a lot of like small products inside big companies, we wanted to move fast and build the best product that we can. So the first decision that we needed to take was like Kubernetes versus serverless. So I know it's a very heated decision, and we had some very interesting talks on the first day of the company, because basically we had me, Ben, the founder, and 2 engineers that joined us from day one. Kubernetes won over serverless, mainly because it felt to us it will be a lot easier to run locally, to test and troubleshoot, and basically to manage dependencies between different microservices. We didn't really need super fast scaling or something like that, where Lambda really excel or serverless excel. The thing that like was really important to us is to think about the day-to-day working and day-to-day troubleshoot, not the time it gets to get started, because I think Lambda would have been like faster, like getting your first server on the air. But we thought like the maintenance and the toil later will be a big disadvantage. I will say that like our team, we all know Kubernetes quite well, and our product is Kubernetes, like is dedicated for Kubernetes users. So it is a bit tricky, but I think for a small company, it might be debatable. And I think that Kubernetes overall gives you a better and easier way to manage things rather than serverless. The second decision that we need to take was microservice versus monolith. So I know like everyone is talking about microservices and how great it is, and it lets you to scale to infinity. And as your team grows, there are no problems. So we started using microservices at first. After like 10 or 15 microservices, it felt like it's too much to handle and to manage. So basically, we created one big service. I won't call it like a monolith, but one big service. It was too big, so we did split it up. And now we are in a process of like migrating or merging like the existing legacy microservices into one or two microservices. And our goal is to have 2 or 3 services. And basically, like the main problems with the microservices was running locally, testing, and the dependency between different microservices, because you update one microservice and then you need to update like 2 or 3 more, and it's just tedious, like we're doing like the day-to-day working. I think that if we would invest more time building like the right set of tools, it could have been better, but we didn't really wanted to spend time on those decisions. The third decision was monorepo versus multi-repo. I had like a lot of experience working with multi-repos. Basically, the biggest issue is syncing dependencies in a multi-repo environment. Think about like you have a backend and a front end, and they have some, I don't know, GraphQL schema between them. So if you update one, you might need to update the other. And then a lot of companies are building their own automation tools in order to solve it and to streamline the process. Basically, in Comodore, you have everything in one single dir. In one single repository. Each microservice is its own dir, and we have one shared directory. The deployment part is also part of the repo and part of each of the microservices, and the deployment is done via umbrella chart. So everything is basically deployed together. And I think monorepo is super cool and the right choice for a small team. We did that work in order for us to be able to split it later on if we will need it, but it gives you a lot of like very, very integrated system without the need to build in this integration using external tools or GitHub Actions or things like that. Okay, so this was like the first decision that we took in Comodore, and now let's talk a little bit about CICD. So again, we're a small company. What we try to do is commit, merge, and deploy, and having the features as fast as we can into productions. We spent a lot of time removing the barriers to move from development to production. I can say that it was a time waster at the start, like making sure all of the infra works as expected, and we did do a couple of iterations on that. But overall, it gives you a very agile team. And because each developer is responsible for pushing to production, he's also responsible for basically making sure that when things go wrong, he's on top of that and he can manage the issue. So I really recommend it, like as a state of mind. And like the interesting thing that we done in this area is using Docker to the extreme. So we use Docker multi-stage build, and for those of you who don't know it, we have like the base image, then we have a test phase, and then we have like the finalized image. And basically, the testing is done via Docker build, and this gives you like the ability to utilize the caching capabilities of Docker across builds and across like different branches. We started with Circle CI as it was our go-to tool. We already knew it. It was super easy to get started as we had more and more microservices. It was kind of a bummer, like writing YAMLs. So we moved to BuildKite, which is like a new CICD tool. Basically, they don't allow you to host like the agent on their site. You must like host it by yourself. But it helped us like reduce the build and deploy time from 6 minutes in Circle CI to less than 1 minute, basically because better Docker caching. It's a lot cheaper, and we use Python instead of YAMLs, so super cool. Instead of writing like 500 YAML lines of code or YAML code, we ended up having like 30 lines of Python. So if you can, Docker can really simplify a lot of things, and you should use it. And also don't be afraid to experiment with new tools. It might really pay off. We were a little bit skeptical with BuildKite at first, and it crashed for like the first few tries we gave it. But overall, we're super happy with it at the moment, and we don't experience any issues with that. The other cool thing that you are big believers is feature flags, and more specifically, launch darkly. We wanted the ability to open features without the need to go over like the CICD, and basically to go and have open only for a specific segment. So for each front end new feature, basically we open it up only for the Komodor tenant, and we see the changes for us, and then we open it for other customers. And again, it allows us to deploy things faster to production. And like I said, like on the first slide, production is the only place that really counts, and we try to remove the barriers moving to production. Okay, so now let's talk a little bit about monitoring. And we had like very, very good monitoring right from the start. The main reason is not only like it has some things to do with your business reputation and making sure you're always up and customers can log in and see the functionality that you promised them and that they are paying on. It saves you a lot of time troubleshooting. And our goal is when we have an incident, when we have an issue, when we have a customer that is complaining, we have the right tool for the job to understand very fast what's the issue and what we can do to prevent it for next times. So basically, it allows you to know that you have problems before the customers, and it's a lot harder to add monitoring like in retrospect phases, like making sure you have it baked in from the ground up. And I will say again, the main reason is the fact that it saves a lot of time when you are troubleshooting, which is a lot of the developer and DevOps time. So the main tool that we are currently using is Datadog. We use it both as an APM, as an infra monitoring, and as a testing tool. It works seamlessly with our stack, which is AWS, Kubernetes, and also Python and TypeScript for the APM parts, and also Golang. We are extending like the base capabilities. We send like custom metrics or custom traces using the Datadog SDK. It allows us to create really simple monitors and custom alerts, and the synthetic and browser and API testing allows us also to mock user behavior on top of the Comodore website, and basically allows us to make sure everything is working as expected. I will say that there are like very good open source, and you can use like Prometheus, Grafana, and Jaeger in order to achieve the same capabilities. We rather like pay the money and not really go into the making sure like hosting everything by ourselves. But it is like a very good stack, Prometheus, Grafana, and Jaeger. The other tool that we are heavily using is Logs.io. Basically, it's a hosted Kibana. Kibana and Lucene are pretty much the standard when it comes to logs aggregation and searching logs. It has a native Kubernetes integration. It's easy to configure new alerts via Logs.io. And we prefer, like, again, paying money instead of holding our own infra. I will say in this space that you have CoreLogix and Splunk and Loki, or hosting like Kibana by yourself. If you are hosting like Kibana on Kubernetes, it's not that hard, but it does require like expertise, time, and we just prefer like paying other people to solve all of these issues for us. And before I go like to other tools, I will also say that we are using LogRocket for like front-end monitoring. We are using Bugsnag to catch exceptions, and we use OpsGenie to alert us when things go wrong. So there is a very big stack of tools that we are using to make sure like we are aligned on the production side. A little bit about like the culture, or how I see like building a new technology or a new like service from the ground up. It's hard. Like you will make mistakes. And I think the most important thing to do is to learn from them and basically listen to the team. And I try to ask my team as much as possible what are the biggest time spender or what we can do to improve. Because let's say that your build time is now 10 minutes instead of 1 minute. It basically means that every time someone is waiting like to make sure that his code is running properly and it passed all of the tests, he go to the, I don't know, like drink some coffee or tea or something like that. And if it was only 1 minute, you will just look at the screen and wait for it to finish. So you need to find those bottlenecks, those time consumers, and try to eliminate them as fast as you can. I will say that even it's hard, it's super fun, like choosing the technology that you want. So it was super fun experience, and we're still building and improving the product. So it's super fun. Another like not so orthodox tool that we are using is Hasura, which is basically Postgres plus GraphQL. It accesses the backend on top of Postgres, like a, let's call it like serverless backend. It transforms SQL schema to GraphQL, queries and mutation. It handles the authentication part, and also the fact that when we add a new column to the database, then we can just use it using like the updated GraphQL schema. And this way, we have the backend that only know Postgres, and we have the front end that only knows Hasura and GraphQL, and it's a really great separation of concerns. We were a little bit skeptical at first, like will it work? Like I don't really believe in no code, but so far it works quite well for us, and I really recommend like checking this tool out. So to wrap things up, I will say that it's super easy building a new service, a new server, like deploying to Kubernetes, deploying Lambda. You read like a 5-minute tutorial or a video on YouTube, and you have your service up and running with a load balancer. It is super easy, shooting yourself in the leg and making like the wrong decisions. And even for us, that we really tried making sure like we are like keeping up with the best practices. Like we had a lot of microservices. We did spend a lot of time on the CICD, and you must be on top of it and constantly like question your current state. Try to talk with people you trust and read real life stories. And because like all tools obviously they are saying they are the best and they will solve all of your problems. And a lot of the times, even when you experiment like for 5 minutes with one of those tools, you see they don't really live up to the hype and for everything like they had in the marketing brochure. So be like, don't trust like marketing materials. And that being said, I wrap up and I will say, like, I didn't mention Komodor, which we are using internally, and it basically allows you to troubleshoot Kubernetes easier, and we are also hiring. And that's pretty much about our journey in the cloud native. Feel free to ask questions, because we had a lot of hard decisions that we needed to make in order to make sure everything works as expected. Back to you.
Thanks, Itiel. It sounds very interesting. You had quite a journey here, so thanks a lot. Actually, your talk is really, thanks. Itiel's talk is really connected to our next talk about metrics that we're gonna discuss. So let me add Yishai to the stream. Just before we talk, just a sec, I just want to remind everyone that if you have any questions about any of the talks that we had today, please ask them in the Discord, and we're gonna have the Q&A panel at the end asking all of your questions. So Yishai, what's up?
Hey,
Yishai.
How are you?
Hey, I'm good. How are you?
I'm good.
So you're CTO at LinearB. Care to comment what's the
So LinearB is a startup that deals with helping development organizations, teams that write software. And our mission is to help them deliver better, help them improve the way they think about software delivery, and eventually be happy.
Mm-hmm. Cool. So you're going to talk to us about cycle time, which is a metric that not everyone knows about and could really help people understand what's going on their systems?
Yep. The most important metric you can think about.
Awesome. Okay, so take it away.
Thanks. So if you can afford to measure just one thing in your engineering organization or in your dev team, it should be cycle time. And I'm going to spend the next 15 minutes to talk about cycle time, why it's so important, and how you can win with cycle time. A little about myself. So like Hila said, I'm with LinearB. We are a pretty young startup. We've just announced a large round A, and our mission is to help dev orgs improve the way they deliver software. This is all about software delivery intelligence, which is the sum of the methods and approaches and technology that helps dev teams become elite performing teams. So you want to be data-driven. You want to have something to base your understanding of how your most important team works. Your most important team is your dev team. And like Itiel mentioned earlier, you want to be very swift about delivering value all the time. You want to go through that cycle of write some code, get it in the hands of customers, learn and improve. So you want to measure things. But engineers are in many ways like artists. Writing code is a creative process. It's very hard to measure the muse, or it's hard to measure the output of a specific engineer and hope that that will actually get you somewhere. So maybe you're thinking about, how do I start measuring my dev work? Or you could already be doing some measurements, but you're measuring the wrong things, like velocity or lines of code. You're comparing your engineers one to another and maybe killing the culture. So what I'm going to suggest here, and this is based on a lot of research, not just ours, is to move your focus from measuring engineers to measuring the team, to measuring the process, understanding the process that gets code from an idea to a working product, and look at the main productivity killers that really hamper the way engineers and engineering teams work. These are context switches. Everyone knows that if you want to work on something that is creative, that is maybe difficult, that needs brain power, you want to be in the zone. And interruptions, these could be instant messages or other tasks. Any kind of context switch is really going to drain your ability to promote the important things, and is also going to make your life more miserable. A work in progress culture, focusing on many things at the same time, having too many balls in the air, starting to work on things instead of getting things done is another productivity killer and another cause for, oh, you did so much, but nothing actually made it beyond the finish line and actually created value for the company. And then there's dead value. If you think of it, when you're writing code and eventually merging into your code base, but if that code is not deployed, Itiel said it a few times, and I completely agree, production is everything. If your code is not in production, if it's not in the hands of customers, this is dead value. Until you deploy it, you have gained nothing, you have learned nothing. So we will focus on these through looking at the cycle time. So what is cycle time? Cycle time, and this has been, again, researched, and you can go into more depth in sources like Nicole Forstron's Accelerate book, or look at the DORA metrics. There's a lot of research and empiric evidence showing that focusing on the process through cycle time is one of the key ways to separate elite teams from the rest. So cycle time is about how long does it take my team to deliver a piece of work from the beginning to the end. That piece of work could be a bug fix, it could be a small feature, but any piece of work that my team is able to push from beginning to end quickly, if I can do that and my team can do that repeatedly, small chunks of work, they all reach production quickly, I have a low cycle time and I'm performing better. So you can think about this as like the RPM on the engine in your engineering team. And to better understand how cycle time really captures the entire process, we can look at the main segments in cycle time. So the first segment is coding, and this is basically the developer, typically a single person, sitting in front of the code base and a requirement and building some change. They could be fixing a bug or creating a fancy new feature or refactoring some existing piece of code to make it better. But they're basically proposing a change to the code base based on a requirement. When that phase finishes, now there is a change, typically a pull request or a merge request or similar. And modern teams use code review and similar methods. So I have a change I'm proposing, and now I want someone to take a look at it and give me a code review before we actually merge it. So the next phase is pickup. This is about waiting for someone to take a look at my code, getting someone's attention in the team, getting that person to free up and look at my code. All that time is basically dead in terms of value. Nothing happens beyond waiting for someone to start looking at my code. Once they start looking at my code, we are at the review phase, which is about everything that's needed to be done to review the code, to address the changes and the review comments. Maybe I need to rewrite the entire code again, get the people to look back at my changes after I've made them, maybe get into some argument about what are these changes required or not, or they could be wrong, I could be wrong. Eventually, multiple people, at least a developer and one reviewer, but sometimes more, need to agree and push the code to a state where it's ready to be merged, ready to be considered part of the code base, the stable code base. So review will take from the initial beginning of taking a look at my code until my code is merged. And then finally, the deploy phase is about taking that code which was merged and measuring the time it takes until that is actually in the hands of customers. It's in production, and production can vary in many ways for many dev teams. But the key is that now it's actually bringing value. The whole reason I set out to do this piece of work is to get it deployed and put in the hands of customers. Production is everything. And understanding that time it takes the organization to push things to production is crucial. So how do we win with cycle time? How do we take our existing team and improve so that our cycle time becomes lower, more predictable, and we gain all the benefits, which I'll discuss. Again, it helps us to look at the different segments. They each have different dynamics, which impact the time it takes for each segment. So let's take a look at each of those and see what we need to do to get better at each. So we will start again with coding. A single person sits in front of a requirement and is building a change in the code base. What will affect the coding time and make it longer? First of all, the requirements, they may not be great. And maybe I start coding a new feature and then discover that the requirements are not complete. There are some edge cases which are not defined, or some other things that were not thought through. I need to go back and discuss this with product or whoever is creating the requirements. This is immediately going to impact my coding time and make the time I spend writing this piece of change to the code base much longer. The other thing, so getting better requirements and getting better at having the requirements well thought out before I start coding is a crucial thing for winning at coding. Chopping down the work and focusing on one thing instead of trying to combine multiple things or multiple concerns into a single change, a single PR, is again a crucial skill for the team to learn. If I'm working on a feature, don't fix that bug which happens to be in the code next to the feature you're working on. If you're refactoring something, don't try to push in another feature at the same time. Split the work so that you can focus on something, get it finished, get it deployed, and then do the other thing. So chopping down the work is going to help across the board. And then there are places in the code which are hard to make changes in, and whenever I need to touch those, it's going to take me more time to make sure I'm not making any mistake. It could be a great investment to refactor those away and remove those hard parts of the code so that coding of the next feature becomes much shorter and easier. So that's for the coding phase. Pickup is all about coordination and communication in the team. It's basically waiting for someone to start reviewing my code. So I need to get better, and the team needs to get better at communication, at being aware that things are waiting for people or for anyone to pick up. There are technologies that you can rely on to help you alert the team of things that are waiting for pickup. And again, it's back to communication. It's harder now that we're all remote or semi-remote, but that's how you improve pickup. Another tip that really helps with pickups is what we call deliberate context switching. Developers are typically writing code. They're busy writing their features, working on their own code. Doing code reviews is almost by definition going to require a context switch. So why not be deliberate about it and wait for the context switch that is already happening and decide to do some code reviews at that time. Maybe I'm finishing a meeting, I've just begun my day, I'm back from lunch. These are all great opportunities to take a look at the pickup, take a look at waiting PRs that need to be looked at before I dive into the zone and work on my thing where I do not want to be interrupted. Then the review phase is a little more complex. It has both the coordination side because multiple people need to be involved. The coder, the reviewers, there could be multiple cycles. So a lot of coordination and communication. But to really get better at review, you want to instill a culture where done is much better than started. I know that I really like to start working on cool stuff. I like that much better than I like to finish the task and get them over the finish line and into the hands of customers. So you have to fight that tendency, and as a team, preferred finishing things, getting them over the finish line and into production before starting new things. And review is typically the place where things get stuck. Some teams need to add reviewers. They need to make sure that more people can review other people's code so that they're not a bottleneck, and having a high review part of the cycle time can signal that you have a shortage in reviewers. And sometimes the review will take long because I need to rewrite my code because I did not think it through. I need to do better tech design up front, or get other ways to vet my directions before I invest in coding, only to get a very critical review that will require me to do a lot of rework in my code. And then finally, deploy. This is sometimes out of the hands of the direct engineering team, but hopefully more and more teams can impact their future here. So obviously, investment in CICD and in ways to continuously deliver. You need to invest in your tests, have them more reliable, more comprehensive, so that you are comfortable deploying more often. Having smaller pieces of work highly reduces the risk of deploys and helps you to deploy faster and more often. So those kinds of investments really let you shrink the deploy time and overall win with cycle time. So some of the benefits that elite teams, the ones that really have cracked cycle time and are able to continuously push value through the cycle. These benefits, I'm going to recount just a few. First and foremost, you have a much shorter learning cycle as an organization. If you're able to push value to production quickly, you can get features in the hands of customers, learn from their feedback and behavior, and repeat. Crucial for startups that are just starting. I think Itiel mentioned this. That cycle of getting something, incremental updates to your value and learning back is crucial. The better you are at cycle time and that kind of delivery, the better cycle that you'll have. Having shorter cycle times mean less work in progress, less items that are spread over days and weeks, much less context switches because there are less tasks that are current and active. And by forcing you to have smaller chunks of work also means that you are dramatically reducing the risk of delivery. You're not creating huge bundles of change that now are an integration hell or a delivery risk. You can be much more comfortable releasing all the time. Cycle time can be improved and pretty quickly. Here are some numbers that we have seen from our customers. By starting to look at cycle time, by starting to measure that, and by starting to address the different segments, you are really able to improve. And we've seen improvements of 20, 30, and even 50% of cycle time in a majority of our customers after they start really paying attention. And then finally, metrics or measurements is just the first step. It's a great first step. You have to do it if you really want to get great at software delivery, but it's not enough. So you start with visibility, which is metrics. But first of all, like everything else in life, this is a 80-20 or even a 90-10 case. Most of your pieces of work, most of your branches or your PRs are going to be okay and small and nimble. A few are going to be much longer and will impact your cycle time. So understanding where those problems are and being able to isolate them is a move from metrics to insights. And then the next move is to actually, let's not wait to have a metric and say, okay, we had a problem, how do we improve it? We can bring some of these insights into actions and really let the team interact with the issue as it's becoming, before it becomes a large issue. I'll just give one example. If I have a pull request that's waiting in review, it's waiting for someone to pick it up, it's in the pickup phase, we can alert the team and tell them, this is waiting for too long, why didn't you pick it up? And by moving from a metric to an action, you're now really able to take it to the next level and reduce your cycle time across all of its segments, automate some of that work away, and really become one of those elite teams that are able to push value day in, day out, like every modern team should. So that's it for me. Invite everyone to join our Dev Interrupted community for dev leaders or listen to our podcasts. I mentioned we just closed a large round and we are hiring. Reach out to me or use the link, a bunch of open positions. And I'm also inviting everyone to start measuring your own cycle time. We are free for small dev teams, so just hit the link to register or reach out to me to learn more. Thank you.
Thanks, Yishai. That was great. Very insightful as well. And now we're going to go to the Q&A panel. I'm going to add everyone to the talk. Hi, guys.
Hey.
Did you have fun?
Yeah,
Yep.
Sure.
Awesome.
First time Discord, to be honest. So I hope everything went as expected.
First time's a charm. Okay, so we have some questions from our Discord people. First question is to Yair from Entways. Why do we need the historical background? Don't you believe that, as Sting said, history will teach us nothing?
Well, this sentence by itself doesn't make any sense at all, of course, right? Because no matter what kind of history you're doing, you can learn something from history. So by definition, this sentence doesn't mean much. It's a bit of a trolley thingy. That might sound cute, but it's not serious. So that's my answer to that. What I meant is you don't need to be an historian to understand the things. And I think Yishai and Itiel talked about the same concerns. I think the idea is to have a critical, independent thinking. And it's more about asking the right question. For example, why are we using Kubernetes? Why are we using microservices? Why do we want to monitor CPU on each machine that we are running and not checking thresholds on APIs? And saying that sometimes monolith is a good thing. I'm not saying what is good or what is bad. I just want to ask the question.
Okay, cool. And actually continues with the question to Itiel. When are you splitting the mono repo?
Yeah, like the mono repo works really good so far. So I don't see it even in the near future. Maybe we'll use like a tool to manage it better, maybe Bazel or something like that when we'll be a bigger company. But like I think both Google and Microsoft are working like monorepo quite heavily. So I think it can scale if you have the right tuning. So yeah.
Okay. Question to Yishai. Okay, I get the cycle time. What are the next metrics I should be looking at?
Yeah, so after you've mastered cycle time, you can go with the additional DORA metrics, things like the deploy frequency, which is, it's a dual to the deploy time and cycle time, understanding how frequently you deploy. You can look at measuring the size of your changes, the PR size or similar, and making sure that you are getting great at cutting down work to small chunks. Or you could focus on things like measuring the quality of the code reviews. We all use code reviews, but there's a wide variety of like, how good is my review process? Is it impactful? Is it actually meaningful? So measuring things like the depths of the review, the number of cycles, the back and forths, who's doing review to who, or to which pieces of the code base. These are all like second level insights that you can go into to really understand what's going on and further improve.
Okay, cool, thanks. Another question for Yair. Can you give an example of a company that didn't really adapt the DevOps culture and concepts, although it had a suitable technology? And also, if you have another opposite example as well?
So I can give an example. I can name names, of course, but there were two companies that actually asked from us to do the same thing, basically move from a more monolithic to a more, I would say, microservice-y or Kubernetes cloud native. Both companies got, in a way, what they needed on the technical side. One company just didn't have the right culture. So although they had Kubernetes and they had GitOps and they had terraforming and everything worked really nicely, they actually didn't know how to go to that step. Like we tried to teach them to do small POCs and to refactor their code, but they had not the capacity on a cultural level to go there. Well, the other company just ate it alive and we're already doing short increments. So the idea is to move. The technology by itself will not allow you to become high performance, as Yishai says. You need to have something that correlates to that. It's not enough.
Fair enough. Okay, so I think we have a last question for Itiel. The technology choices that you mentioned throughout your talk, do you have any thoughts along the way of, okay, this was suitable for us at this point of time, but might not be the best choice for our needs today?
Yeah, I can say that we have a process. We have like some parts of our system that we know they won't scale. Like it's obvious to everyone. They are not like the best practice. We use like Postgres too heavily on some use cases and so on. So there are areas that we know that they are not like they won't scale, and we will change it once we have like the right amount of users or manpower to improve. So there are like things that we know that aren't that good and we will improve. But a lot more tricky are the things that you feel that work as expected and you don't really talk about them on a daily basis. And then you ask one of your developers, why did this feature took, I don't know, like a week instead of 2 days? It was, I saw the pull request. It was quite small. Like, where was the time spent? And he or she answers you like, it was super hard testing it locally because we didn't have the data from production. So I spent 4 days, I don't know, like getting the data from production to test locally. And like, it's to find those areas that no one really thinks about and to see how we can improve. And I can say like, this is a real example. I didn't thought that we have a testing problem until I found out a lot of the feature takes a lot of time because we don't have testing, like good testing infrastructure in place. So those are the tricky parts, not the parts that you say, okay, I know I need to move from Postgres to S3 in a year or so as the database grows. So no process, just like a weekly checkups. Yeah.
Okay, cool. So we don't have any more questions. So I want to thank you guys for being with us. Your talks were very insightful, so thanks for that. And thanks. So thanks, everyone. I was Ila Fish, and I would like to thank you all for being with us. Make sure, please, to answer the survey that we have. This will really help us to understand if we can make an in-person conferences later on. And yeah, I think that's it. Thank you. Bye-bye. Oh, right. Sorry, guys. We have the next meetup. We will really be thrilled for you to be there as well. 20th of April, next meetup. All details are here and also in the meetup.com. Join us. Thank you, guys.